So this week is review week, and there are a lot of review opportunities. um, so you've got that it's a little bit unconventional. You don't have a mandatory quiz, but you do have a mandatory activity, right? So activity 10 is going to be a review activity. It's pretty much what we're doing in the review today. You get to do again, but it's graded. And it's pretty similar to last week's activity where I give you a scenario, you pull out the information. If you have an output that I give you, then you just pull information out of the output. If you have to run the test, then we're using SPSS. But that activity will be due on Monday of next week. And the exam review quiz, which is extra credit, will also be due on Monday if you decide to take it. And it'll just be on stuff we cover in the review today. But you can see that brings us to 90%. So literally next week, the exam, that is it for the class. And again, I'll send each of you an email with your final grade after I've finished grading exam 3. That way you can decide if you want to take the final or not. The way I have the review set up, you have data sets to go off of if you want to practice running each of the tests that we have in the practice problems. But I've also posted the outputs for each of the data sets that we have in the review. So then if you run the tests on your own just for practice, for procedure, you can kind of compare your output to the outputs that we've got. And then normal activity stuff. I do want to give you guys a little sneak peek on the exam. Just for dates, it's going to be on Wednesday. Usually we have exams on Mondays, so just make sure you block out at least 2 hours, 3 hours if you want to take your time, and like just double check work and be thorough. But it'll be on Wednesday instead of Monday, and that's so that I can get your activity graded and give you feedback before you take the test. In terms of outputs, you guys will get an ANCOVA output and you will also get a MANOVA output. Okay, and these will be paired with a research scenario, so they'll be pretty similar to what we're reviewing today. I think there's like 30 questions. There will also be, I am kind of brainstorming dissertation ideas, so I kind of put this like a project proposal together that has some methods that are introduced, and then this kind of aligns with our evaluating the literature lecture, where you're just going to criticize the methods and then based on the variables that you see, maybe suggest what type of statistics could be run. There are multiple answers for this. I kind of made it a little bit vague for a reason. That way it's a little bit more open to interpretation. The other thing, just like last minute housekeeping stuff, the post-semester survey will also open up next week and it'll end by the end of finals week. So this is more specific questions that I have on your experience in the class and the course design and different course components that I used. It is for extra credit. You don't have to take it if you don't want to. Spot evals are also available for you guys to take. So those go towards my lecture evaluations on some type of annual basis. I don't know how many times I'm actually supposed to get evaluated, but they are helpful in like getting me rehired. So if you think I did a good job, then feel free to add some input there. Okay, that's enough of that. Let's get to business here.
Natalie, before we get going,
Yeah.
if you go back to Beachboard,
Huh?
the if you go to the course resources and materials,
Yes.
the exam three stats test summary is not uh,
Oh, okay.
loading.
I can check that. There, Beachboard had an update a little while back, and a lot of the course content that worked at the beginning of the semester when I posted it no longer works, which is really annoying. But I will repost that. Let me make a note really quick, and
Yeah,
I'll do
neither
that.
the blank one nor the one above it work.
Okay, I'll do that after class.
Thank you.
No problem. Um, okay. So, um, okay. So the review problems for each data set, I've given you a description or like a scenario. So it'll pretty much be similar to what you guys have been doing. We're identifying variables, variable types. Based on that information, we pick which test we would want to run. Um, so for our purposes, just so we can get through as many examples as possible, we will just look at the outputs that I've already created. But again, if you want to practice running procedures, that's a fair thing to do. Um, on the exam, you will get at least one type of each test that we've covered. So you'll get, I already showed you, you can expect an ANCOVA output and a MANOVA output. And then I think I have two of the three two-way ANOVAs. So you'll either get a between, a within, or a between, like any combination of those, any combination of two of those three tests. English. And then I think my first example in the review is a one-way ANOVA. And so because you need to be able to pull out different types of one-way ANOVAs to create MANOVAs if there's multiple dependent variables. I still have an example of like one-way stuff. I don't remember if I have one of those on the exam though. I'm pretty sure I took it out. There might have used to have been one, but anyways, you want to know the assumptions and the interpretations. You would only provide p-values for the assumption tests that you run in SPSS. Okay, so in terms of listing assumptions, that's like normal distribution, random sampling, if you have a between subject factor, homogeneity of variance, if it's within subject factor, sphericity, right? But you would only put the p-values for the actual assumptions that are run through SPSS. So for all of the tests that we've run so far, this would either be homogeneity of variance, sphericity, homogeneity of regression for ANCOVAs, and independence. So I think I've had some of you come into office hours or email me questions. And I think there was a small point of confusion with the MANOVAs that the multivariate test in SPSS, like that is in line with like the with the oh, I can't even speak now. It comes with the multivariate analysis, which you didn't have to run it, but I think there was a bit of confusion that multivariate table was like presenting the p-values for the multivariate normality assumption. Remember, we cannot test multivariate normality in SPSS. It's just not possible with the technological capacity of the program. So For MANOVAs, we add multivariate normality and the homogeneity of variance covariance. Neither of those is going to be having a p-value reported for it. So if you need to list the assumptions, they can be added into a list of assumptions, but they don't need to be reported on. The multivariate test in the MANOVA output is a part of the main effects. And I believe we have an example of that. Yes, we do have an example, so we'll go over that when we get there. But I just wanted to make a note that these are the ones you would report p-values for. P-values for main effects. Again, these are going to be like, think about what the purpose is of the test that you're running. So like the purpose of an ANCOVA is to see if there are significant differences between groups when you're controlling for a covariate that's been measured, right? And so the main effect is going to express some type of interpretation of a p-value that is contributing to that purpose, okay? Interaction effects will be applicable only to two-way ANOVAs, so just remember interaction effects are also main effects. And then pairwise comparisons, again, only if applicable if you've got significant effects or interactions. I have additional notes here. If you have an ANCOVA and the homogeneity of regression is violated, similar to your activity, just note there was a violation, but keep going with the analysis just for the sake of the practice. And I think the one on the exam is good, but if not, I probably added a note similar to this. But I'm still finalizing some of the exam questions, so I can't remember. And then again, just in case it didn't hit home yet, you don't have to test these two things in SPSS. Okay. All right. I'm going to go ahead and skip dataset 1 for now, just because I can tell you already it's a one-way repeated measures ANOVA, so you guys should be fairly comfortable with this. And I want to make sure we cover most of the new stuff. That way you have the opportunity to ask questions. So we'll skip that one for now, and we'll start with data set number 2. Reviews are always hard because I can't see you guys and I can't see the chat. So if you have something you want to contribute, either answering a question or asking a question, just yell at me or put something in the chat. Hopefully I see the notification. Okay. Any questions before we get started? I know I just like word vomited a bunch of stuff at you guys. Oh, chat. Yeah. Oh, question for what assumptions you're supposed to report for p-val or in terms of p-values for MANOVAs. It would be the assumptions that you have for your like regular one-way or two-way ANOVAs without the multiple dependent variables. So if you have like a one-way repeated measures MANOVA, you would only report sphericity. So just the ones that you're used to reporting, pretty much.
Can you repeat that you just said one more time, please?
For MANOVAs, you're just going to be reporting the assumptions that you're used to reporting for the base ANOVA. So any of these, particularly for MANOVAs, it's at least with the examples that I give you guys, it's either going to be homogeneity of variance or sphericity.
Right, meaning it's going to be a one-way or RM ANOVA.
Yeah, so if you had a one-way repeated measures MANOVA, you would just report sphericity.
Okay,
In
that's
terms of
the
a yeah, in
assumptions.
terms of a p-value at least.
Gotcha.
Yeah, good question. Okay, let's do data set number 2. So, a study evaluated the effect of inspiratory and expiratory muscle training on pulmonary function and maximal exercise performance in competitive triathletes and marathon runners. The participants in this study, and being sample size being 30, had a mean weekly aerobic training time of 7.5 hours per week of swimming, cycling, or running. 14 subjects were assigned to a pulmonary resistance treatment group, and 12 control subjects were given a sham device that allowed no greater than 15% resistance on inspiration or expiration. The subjects performed 30 maximal inhalation-exhalation trials on their respective devices 2 times per day for 4 weeks. Subjects' forced vital capacity, or FVC, was tested before and after training. In this study, pretest measurements were used as a predictive baseline in reference to each subject's respiratory function before analyzing between group differences for the effects of the respiratory training on maximal exercise performance. I'll give you guys a second to think about what I just read to you. And then if you think you know what the independent variable would be, you can shout it out or put it in the chat.
Would it be inspiratory and expiratory muscle training for the independent?
Yeah, the type of training program. Mm-hmm. So we'll just call it training program. Um, we've got pretty much 2 groups, right? There's the ones that get the pulmonary resistance, and then the other people, it's basically like a placebo group. So in terms of levels, we would say there's 2 levels, which if we have levels, that means we've got nominal data. And is this a between or a within subject independent variable?
Between.
Between, right? Because we have 2 separate groups. Okay, so those are the things that you would want to be able to pull out for the independent variable. What is the dependent variable?
Is this the pulmonary function and max exercise performance?
We could phrase it a couple different ways. We could call it maximal exercise performance. We could also say, like, what is their respiratory function as measured by forced vital capacity. So I'll put all of those options here. Respiratory function. Oh, my keyboard just decided to not work. Maximal exercise performance. Or you could put FVC, also acceptable. Okay. And per usual, dependent variable is ratio data. Are there covariates?
Yes.
Yes. What is it?
Could you just say pretest measurements?
Yeah, that's fine. Right. Also, ratio data. I don't usually ask you guys what type of data the covariate is, but it should be ratio or parametric, if we're being a little bit more general. Okay. So based on this information, what type of test should we run?
And ANCOVA.
Uh-huh. An ANCOVA. So again, you can put one way if you want to, but ANCOVA would also be counted as correct.
If you go through like the stat sheet summary, with the information given, since there's two levels of that independent variable, wouldn't the technical test be an independent t-test?
Yeah.
So you just don't want us to do the t-test?
No, because you're using the covariate. As soon
Oh, okay. Since there is a covariate, but that lets you know right there that you want to use it in ANCOVA.
Right.
Gotcha.
And I have
Okay.
I gave you guys a freebie answer in the activity for this week, activity 10, because there's a similar example that I give you guys. I think it's for the first data set in activity 10, but it's technically like an expanded t-test because again, there's two levels, but there are multiple dependent variables. So in that one, it's like a one-way MANOVA. I don't remember what the samples are, but in cases where you have two levels only, but you're introducing a covariate or you have multiple dependent variables, you have the choice to do an ANCOVA, or in the case where you have multiple dependent variables, you could have the choice to do a MANOVA. But just remember, like I think I mentioned in last week's lecture, those test options may not always be the best choice for your particular project if you are the researcher. For the purposes of our class, we just say, this is what we're going to do because these are the tests that we learn. But yeah, no, that's a good question to bring up though. But because we have the covariate, we're going to say it's a ANCOVA. What are the assumptions for this test? I will start us off. Normal distribution and random sampling. What else?
Homogeneity of variance and homogeneity of regression.
Y'all?
And then independence between covariate and between.
Independence. These are the ones that I would want you to include. If you wanted to also add information about the variables, that's fine. But if you're giving a list, those ones absolutely have to be listed.
So between, in this circumstance, it'd be just between the pretest measurements and the training programs, or yeah.
Wait, what's your question?
For that, you said you on the test you'd want us to actually like be descriptive, right? For that part.
Oh no, if this is like similar to the activity you guys had last week. So if I'm asking you just like list the test assumptions, you just provide a list.
Oh, okay.
Yeah, but these are the ones that I absolutely want you to list for the ANCOVA. You could also put like there's at least one leveled independent variable, at least one covariate, that type of thing. But because there's a lot of variability that could come with those descriptions, you don't have to add them. Okay, so p-values for assumptions tests. We have 3 that we should be reporting, right? So homogeneity of regression, we'll have homogeneity of variance, and we'll also have independence. And actually, I'm going to put that one in between just so the order is nice. Okay, so if we look at our So let me hide the meeting tools really quick. Data set 2. There we go. I was like, this is not what we're supposed to be looking at. Okay, so if we're looking at homogeneity of regression, woohoo, we have our test of between subject effects. So what is the p-value for this assumption test?
We use the interaction, so it'd be point or less than 0.001.
Mm-hmm. All right, so that one there. So what does this mean?
This would mean that the regression slopes are not equal between the training programs.
Mm-hmm. Right, because 0.001 is less than 0.05. Means we have violated our assumption. Okay. So again, you would want to note p-values, say that we violated your assumption, which means that the regression slopes are not equal, right? But we're going to continue the analysis anyways, because that's what I told you to do. Okay. So then we can look at independence, which again, we test independence by running a one-way ANOVA between the independent variable and the covariate, using the covariate as a pseudo-dependent variable in the actual analysis setup. So, here's the graph if you wanted to look at it. But we've got our one-way ANOVA here. We would look at our homogeneity of variance for the one-way ANOVA. Again, this one is not the one. It's not what you report for the actual homogeneity of variance assumption for the ANCOVA. But based on this p-value, right, would we read the ANOVA table or the Welch's table?
ANOVA.
We would read the ANOVA table because our homogeneity of variance is greater than 0.05, which means that we have relatively equal variances. When we look at the pretest values amongst our training programs. So if we're reading the ANOVA, we have a p-value of 0.524. So p equals 0.524, which is greater than 0.05. So what does that mean?
You accept the null, so the training programs have no effect on the pretest measurements.
Mm-hmm. Training program, and I'll put in the variables too if that helps. Training program has no significant effect on pretest. We'll call it pulmonary function, that's fine. And that's our covariate. Okay, so that's what we want. That's a good thing. Check, check. And then we can look at our p-value for homogeneity of variance, which we'll find in the univariate analysis section. Okay, so we can see we've got our resistance training group and our control group listed by program. Our dependent variable are our post-test results. And then we can see Levine's test here. This is the one. This is the one. Okay. anybody watching this after will just be like, oh my God, she's so annoying. But this is the one. Okay, so we get a p-value of 0.651. And what would that indicate? Wait, what am I doing? 0.65. It's greater than 0.05. So
just equal variance is assumed?
yep, so we've met our assumption.
And it's assumed for equal variances among independent, dependent, and covariance? Or is it just
Good question. It's just going to be for the dependent variable. So this one is similar to like a one-way ANOVA when we get the homogeneity of variance results. It's usually telling us that we have equal variances of the dependent variable measures as categorized by the groups of the independent variable. So,
gotcha.
Yeah. If you put equal variances assumed between training groups, that's totally fine. Or between training programs. Yeah. Any questions on our assumptions for an ANCOVA? So again, you're only reporting the ones that we're used to reporting p-values for. Okay. So then we can look at the main effects, which are after the second Levene's test in our test of between subject effects box. So again, post-test is our dependent variable. And we're going to be looking at what p-value for the main effect of our ANCOVA.
Don't you use the independent variable? So it would be program. So it's 0.004.
Yep. Okay. So again, remember, if the purpose of the ANCOVA is to see how the independent variable affects the dependent variable after you've controlled for the covariate, we still want to know the independent variable effect on dependent variables. So that's why we would read the program row. So our reported p-value is going to be 0.004, which is less than 0.05. So what does that mean? How would we interpret this?
So since it's less than 0.05, we reject the null. And then we state that the program does have a significant effect on the respiratory function or maximal exercise performance.
Yeah.
When controlling for the covariate.
Yep, exactly. Pretest values, that's fine. Yeah, I like it. Okay, so remember the null hypothesis for an ANCOVA is that there is no significant difference between the independent variable groups, right? Or the independent variable has no significant effect on the dependent variable when you're controlling for the covariate. So if we reject the null and we replace independent, dependent, and covariate variables with their respective names, we end up getting this interpretation. Similar to the last exam and all of your activities, make sure you actually use the variable names. Don't just put IV or DV. Okay. And if we're rejecting the null of the main effect, that means we need to look at pairwise comparisons. So that'll be in our estimated marginal mean section. And since we only have two groups, you could say we can look at pairwise comparisons, but because there's only two groups, that that is the result of the ANCOVA, right? So technically, they're not applicable, right? Or you could put NA. If you decided to say something about the pairwise comparisons, training group would be significantly different from the non-training group, but again, that's repetitive from the main effect. Okay. Any overall questions on the ANCOVA? And I don't have meeting controls up. Oh, someone has something in the chat. Oh, that was an answer to a question. Got it. Okay. Cool. I'm not hearing objections, so let's keep going. Data set number 3. A study was conducted to evaluate the effect of adding weight to an anaerobic output test of running upstairs. 20 participants, 10 male, 10 female, performed tests under 5 different conditions, which were no external load, plus 5% body weight, plus 10% body weight, plus 15% body weight, and plus 20% body weight. Researchers wanted to see what adding weight might have, or what effect, what difference adding weight might have on power output, and if the effect changed for males and females. Power output is given in terms of watts per kilogram of body weight. So I'll let you sit with that for a second, and then when somebody thinks they know what the independent variable is, go ahead and shout it out. Oof, that was a good crack.
Well, the dependent is the power output.
Yeah, we can start with that.
And independent, just like weight added or weight used or something.
So how many independent variables are there? Maybe that's a good place to start.
2.
Okay, so JT said the weight or load, right? So we could look at external load groups, which have 5 levels because we said there's 5 conditions, right? And each of those would be nominal or categorical in nature. And then would those be a between or within subject factor?
Between.
Within.
Class vote. How do I want you to vote? If you think it's a between, put yes. If you think it's within, put no. The easiest way I can think.
I retract my statement. It's between. I mean within. I mean, within.
Okay.
Yeah.
Okay. We've got more votes. All right, cool. So it'd be a within subject because we said 20 participants perform each of the 5 conditions. Okay. And then Morgan, you said that you thought we have another one.
Yeah, it'd be sex.
Mm-hmm.
Like male or female.
Yep.
So 2 levels.
Exactly.
Nominal. And this would be between.
Take it home. You got it. Okay.
If we called it something else on the exam, like not always using your words, do you look at that and you?
Oh yeah.
Okay.
Yeah. As long as I get the gist of what you're trying to say. Like if you put weight instead of external load, or if you just put load, or if you put percent body weight or added percent body weight, it's getting to the same thing. So yeah, you would be
What if you put testing conditions? Because it's like that's what they're altering.
also fine.
Yeah.
Yeah.
Okay.
Okay. And then are there covariates?
No.
I don't see any.
I don't see any either. So based on this information, what type of test would we run?
This one would be the 5x2 between within ANOVA.
Yeah. So we could name this a couple of different ways. We could use two-way or 5x2. Take that back. I want to say 2x5 because I like saying things a certain way. So you could put two-way or 2x5 to identify the type of ANOVA, meaning that it's not a one-way. And then we have to include information about the samples, right? So you could put, if it's, in this case, it's a between within. The reason why I changed this to a 2x5 is because if I'm listing between within, these should be respectively matching each other. So the 2 matches the between subject factor and the 5 matches the within subject factor, or at least the order that they're listed in. So you could call it a between within, or you could use the word mixed. That would also be acceptable. Okay, so a lot of different permutations of combinations that could form the title of this test. And then what are the assumptions? I'll do the 2 easy ones since everybody knows those.
Do we need homogeneity of variance and severity?
Yep.
I said that wrong, but whatever.
It's okay. I can't spell, so I guess English is hard. I didn't even spell that right either. Oh my god. Yikes. It's Monday. All right. So then these 2 would be the ones we would run in SPSS, or that SPSS gives us at least. Okay. And just pay close attention is similar to the second exam. If I ask you like, what is the p-value for the assumption test that was included in SPSS? Like, just make sure you're paying attention to the assumption part and you're not listing the main effect. That was a very common thing that would happen on the last exam. And I was like, no! Because I always try to like warn you guys. And then it just didn't work. So, okay. Let's find these in here. So we've got our different weighted conditions, our different sexes, all of our descriptive statistics. We can skip over the box test and the multivariate test because we don't need them. And we can see the sphericity test comes first. So what is our p-value for sphericity?
0.163.
Yeah. Am I able to highlight? I want to highlight this one. Okay. So 0.163. And that's greater than 0.05. So what does that mean?
Sphericity assumed.
Booyah. Okay. And we can go on living our lives. All right, so I'm going to skip over the test of within subject effects. That's more or less what you guys would want to do. That way we can look at Levine's test to see if we met the assumption there. Okay, so I want my highlighter tool. All right, so we can see the p-values listed for each of the conditions. Again, they are listed based off of the between subject variable. So I think this was a point of confusion for some of you when you were doing your activities, because the within subject or the within subject measurements are evaluated with sphericity. So when we look at them underneath, or when we look at the dependent variable, which is power output, we have to look at each within subject category separate from each other. But in this case, what we're doing is we're saying are the variances equal between sexes or between genders, right, for power output within the no weight measurements. I know that was a lot, so I'll say it again. Okay. So this is looking at, right, are there equal variances for the power output measurements between sexes within each of our within subject categories? Okay. And so we'll get a p-value for each of these. There has to be an easier way to do this. I'm determined. I think, yes, there is. Ha, I win. All right. Although I have to click it every single time. That's super annoying. Okay. So we get all of these p-values. And I'm gonna, hopefully that doesn't shrink the zoomage. Yeah, we're good. Okay. So for homogeneity of variance, we've got a no weight group. We've got a 5 adding 5%, adding 10%, adding 15%, and adding 20%. And each of these is going to have its own p-value. Okay, so P for, I'll move this so you guys can see. P for the no weight group is 0.663, which is greater than 0.05. So for this one, we would say equal variance is assumed. Right? And then do the same thing for the 5%. That P is 0.656, also greater than 0.05. So we can argue the same thing as the no weight group. P for the 10% group, 0.675, which is also greater than 0.05. So we can also say that equal variances are assumed. And if you want to get like super specific, it's equal variances between sexes. We can add that if we want to be thorough. If you put equal variances assumed on the exam, I'd likely just count it as correct, to be honest. Okay. For the plus 15% group, P is equal to 0.008, less than 0.05. Which means we've violated, so equal variance is not assumed. But again, because at least in these tests, what we would have to do is separate out the plus 15 measurements between sexes, and then we'd have to run its own little ANOVA to see what the between subject resulting p-value should be if we needed to make an adjustment. We don't do that. So it's violated, but we're gonna continue anyways. And then for our 20% group, we had a p-value of 0.261, which is greater than 0.05. We can say equal variances are assumed between the sexes.
Question.
Mm-hmm.
I know you didn't talk about it, but when you ran the SPSS on this data, what value you have to look at for interaction effect to then go to the syntax? Is that the variance or the sphericity?
Neither assumption test. That would be in the main effects, which we haven't gotten to yet.
Gotcha. But that's when you go back and redo the syntax?
Yeah.
Okay.
Typically, I mean, you can look at it before you report the assumptions. You could look at the main effects just to cut some steps and be like, do we have a significant interaction? Do I need to change the syntax or not? That way you can just do it right away. But in the appropriate order, we should make sure we meet our assumptions before we accept our main effects. So that's why I did it in that order. But if you have a procedure that works best for you, I say do it. So speaking of main effects, actually, does anyone have any questions on the assumptions before I keep going?
Yeah, I just have a quick question. So even on the test, if we don't meet one of the assumptions, just continue?
Mm-hmm.
Thanks.
Yeah. It should be that doesn't happen, but I can't remember. Okay. So for a two-way ANOVA, we're going to have how many main effects?
Two.
Have,
well, three technically.
Yeah.
Yeah.
So we'll have a main effect for the load, right, which is going to be our test of between subject effects. We're going to have a main effect for sex or gender. Oh, wait. JK. Messed that up. The load was a within subject effect, so that'll be under the sphericity table. Main effects are going to be under our between subject effects table. And then we also have an interaction effect to look at. Okay, so three effects should be listed for two-way ANOVAs. I'll highlight these so that they stand out. And then let's look at their p-values. So Mauchly's test tells us we're in the within subject range. We can see test of within subjects here. So what would be, based on this outcome, right? We've assumed sphericity. So what would our p-value be in our within subject effects table?
Less than 0.001.
Mm-hmm. Right, we should be reading sphericity assumed. Okay, so our p-value for load, for load would be p is less than 0.001, which is less than 0.05. So what does that mean?
There was a significant difference.
Mm-hmm. So amount of added external load has a significant effect on power output. And then because we had a significant effect, this means we need to look at pairwise comparisons for load. Blah, I can't type. Okay. And then while we have it here, we also can see the interaction effect. Again, you're going to assume sphericity for interactions. And I had a conversation with a student last week, I think. I don't know what week it is anymore, to be honest. But I think I had a conversation last week, and if you guys remember, on one of the activities, the interaction effect showed up in the sphericity area, but there was no value listed for it. And I think I have an idea of why that happens. I think it's a pretty good idea. But because we are interested in meeting homogeneity of variance and sphericity for the respective independent variables, it can be assumed that we meet the assumption for the interaction effect if we meet the assumption for the, like, if it's homogeneity of variance or if it's sphericity, right? So if we had like a between, I don't think you should see an interaction effect or a p-value for an interaction effect in terms of the like assumption test. But I know the between within is a very special case where sometimes SPSS will list an interaction under sphericity, sometimes it doesn't. But if you meet the assumption for the independent variable for sphericity and you meet the assumption for Levine's test, we can fairly assume that the interaction effect would also have assumed sphericity as well. So in this case, we would say our interaction effect is also p less than 0.001. Did that make sense? Hopefully. I feel so weird in Zoom because I ask questions and I can't see anyone's responses. I'm just going to imagine angel choir voices saying, yes, we get it. Okay. I just wrote this in the wrong section. Wow. Cut. Paste. Boom. Okay. So if we have a significant p-value, how would we word this in terms of the interaction effect?
So again, there's a significant difference between the sex and load when it comes to whatever you're measuring, the dependent variable. Something like that.
You're on the right track. I would just modify wording a little bit because we're not comparing sex to load. Rather, we're looking, is there a significant interaction between these two when we look at the dependent variable? And the reason I think why we got to be careful with wording is because you can either look at differences in load or differences between loads within sexes, or you can look at differences between sexes within loads. So to generalize it, we can just say there is a significant interaction effect between load and sex in terms of, power output. Does that make sense?
Yeah, it does.
Cool. Okay. So we've got two main effects down. We need our last one to look at the differences between males and females. So that will take us to our test of between subject effects. And what is the p-value for that?
P is less than 0.001.
Yeah. Okay. Which is less than 0.05. So how would we interpret that?
Gender has a significant effect on power output.
Yep. Output, there it is. Okay, so again, anything that has significance, that's not the one I wanted to type it under. Meep. We would need to look at pairwise comparisons. For gender, again, because there's only 2 levels, we can assume that the differences are between males and females only. Okay. But for this part, and I'll highlight this, pairwise comparisons change the syntax. So you only change the syntax when you have a significant interaction effect. If there's not a significant interaction effect, then you don't need to change the syntax. I didn't get any questions on activity 8 on how to change the syntax, so I'm assuming that no one had any problems with that. I think it's more of the difficulty in interpreting how I write stuff. So we'll go through that, those differences right now. Okay, so we need to look at pairwise comparisons for the external load to find out which loads were significantly different from each other. Again, you can skip the differences between sexes. And then we also want to look at our interaction stuff. Okay, so one of the interactions is going to be comparing, let's see, actually I'll phrase it this way, as in how I might ask it. Are there significant differences between genders across load conditions? Question mark. Or we could ask it, are there significant differences between load conditions across genders or within genders? Across or within, those are the like interchangeable. I'll just write both of them. Within genders. Okay. Which one is which? I think that's the bigger question for most of you. Let's do external loads first because that one's easier. We can skip sex because we kind of already know there's a difference between males and females as told to us by the main effect. For weight, on the exam, if you guys put like, oh, there's a difference between 1 and 2, and you just use the numbers, in my answer key, if there are numbers in the output, I have both the numbers as well as what they correspond to. So in this case, if you put difference between 1 and 2, you should be marked correct automatically with the answer options I stick in there. If you put no weight and plus 5%, that's also correct. Okay. How else? Some of you asked on activity 8 if there are a lot of significant pairs, is it okay to put all pairs are significant? Yes. If all pairs are significant except for like 1 or 2 pairs, right? You can also say like all pairs are significant except, and then list the ones that are not significant. That way you're not like listing ginormous lists of stuff. So those are some options for you guys if you want them. But in this case, external load, it looks like only the differences between no weight and all of the added weights are significant. And you can see those are repeated each again. So in that respect, we can just say difference between 1 and 2, 1 and 3, 1 and 4, 1 and 5. Alternatively, you could say there are significant differences between no load and all added load conditions. So I hand grade all of these responses. So again, as long as you get your point across and it's accurate with what is in the output, then you're fine. Okay. And then we can look at our interaction pairwise comparisons. So those will be listed again with the little asterisk in between the two independent variables. If we're looking at, do we have differences between genders across load conditions? The way that you decide which one is which, right? I actually haven't looked at this one yet, so I don't know which one it is. But the between, this part should be the second column. Across should be the first column. So in this one, we're looking at the first column is male and female. The second column is weight. So we're technically looking, oh wait, just kidding. The first column, I hate myself sometimes. Okay, the first column is weight. So this is what we're looking at within, right? Or we're like, when we only have no weight conditions, what are the differences between male and female, right? So you can see the between comparison, and that don't get this confused with like between subject. The between comparison is the second column, or like the second variable, independent variable listed. The within or across condition is going to be the weight, or the first column. So this one is looking at what are the differences between male and female, but within each of the weight conditions. So that aligns with this first one here. Happens mistake, I wrote it that way. So this is a good example of where all of our pairs are significant, and you can write that. All pairs are significant. Don't know why that's in red, but we'll go with it. Okay. Then we can look at the other pairwise comparisons for the interaction. Again, this one is now going to be looking at the differences between load conditions within a given sex or gender. Okay. So the way that I like to organize these is in a bullet list. So if we say, let's look in our male comparisons and female comparisons, and then underneath those, you can list your pairs, and they actually do females first, so we'll do those first too. Okay, so it looks like for females, we have a significant difference between no weight and an added 5 weight, or you can just put 1 and 2. 1 and 2. Meh. Looks like we also have 1 between 2 and 4, right? Another little asterisk here. I think. Did I miss any?
I don't think so.
I don't think so either. Okay, so then we can look at the significant pairs for males. I'll just get rid of that because that'll bother my OCD. Okay, and so for males, we can see a difference between 1 and 3, 1 and 4, 1 and 5. So we'll list those first. 1 and 3, 1 and 4, 1 and 5. There's also a difference between task conditions 2 and 4. And I think that's it. Most of these other ones should be repeated. Yeah. And that would be it. Questions on 2A ANOVAs? We check in with the chat. There was a question, significant pairs in pairwise comparisons is any value under 0.05. That is true. Anytime we have something under 0.05 or less than 0.05, well, in our classes, it'll only be 0.05 because that's our alpha level. Anything less than 0.05 is going to be significant. It's your interpretation of that p-value that is going to change based on if you're looking at a main effect versus an assumption, right? Because all of our assumptions, we want the p to be greater than 0.05 because we want to accept the null hypothesis of the assumption. But for main effects, usually we want to show that our intervention has an effect, right? So typically significant differeces are desirable, but if they don't happen, oh well. Yeah. All right. Let's keep grooving. Data set number 4. Okay. A study was conducted to elevate heart rate values during the aiming process of archery among different levels of experience as well as different divisions of shooting. This might sound similar to some examples that we've looked at already. We can assume that each person is in only one division and one experience level. Values are given as a % of heart rate max. Shout them out, guys. What are my independent variable or variables?
Experience and division.
You got it. Okay. So division, this one you would get information by looking at our example here. So experience, we've got 3 levels, beginner, intermediate, and advanced. Division, we can see we have bare bow, recurve, and compound. So 3 levels for each. And then each of these would also be nominal because they're categorizing people. And then do we have, for division, is it a between or within subject factor?
They're both between.
They are both between. Okay. Because what we're doing is we have, and maybe I could be better at describing this one. Oh yeah, no, I did it right. We can assume everybody's in one division and one experience level. Okay. I was like, damn, did you suck today? No, we did not. We got it right. This is the self-talk that I put myself through on a regular basis, you guys. So it's a good time. What's the dependent variable?
% of heart rate max.
Yes, it'd be heart rate, which is ratio. Covariates?
Did I
No.
see?
No. So what type of test do we have?
3 by 3 between.
I
have heard great things. Okay, 2A, or you could say 3 by 3, and then we could put between, or we could say independent, also is fine. ANOVA? What are the assumptions for that? Starts off normal distribution, random sampling.
Homogeneity of variance.
Oh, yeah. Okay. If you wanted to add information about variables, you can, but these would be the ones that you definitely need to put in there. And then let's go to our output. We can see Levine's test. I'm gonna zoom in. These outputs are small. So for Levine's test, we can see, get my highlighter page up, that we've got a p-value of 0.488. So this is for dependent variable heart rate. You can see it down here, the design is to look at our variances equal between experience, division, and then they're also doing an interaction. But again, if each of the individual groups has met the assumption, we would also assume that the interaction has also met the assumption. So, but we're looking at heart rate across each of our groups to see, are the variances equal? In this case, if P is equal to 0.488, which is greater than 0.05, we have equal variances between divisions and experience levels. Cool. Then we have our main effects. So how many will we have?
This one's going to be 2.
2, and then
3.
An interaction effect. So you can say 2 or 3. It depends, I guess, on how you want to word it. So we'll have a main effect of division on heart rate. We'll have a main effect of experience on heart rate. And then we'll have an interaction effect between division and experience. I'll just put div and exp. Okay. So I'll highlight these again so they stand out. So all of these will be in our between subject effects area because that's all we have to look at. So I think all of you can see experience has a p-value of 0.079. Okay, and we can assume that we can accept the results of this test because we met our homogeneity of variance assumption. What was I just looking at? Experience. So P is equal to 0.079, which is greater than 0.05. So how would we interpret the main effect of experience?
Experience level has a significant effect on heart rate.
So significant or no significant?
No significant.
There we go. Has no sig effect on heart rate. One down. Can then look at division. We see a p-value less than 0.001. So that means what?
Means that there's at least one significant difference between the divisions.
Yep. So has a big effect on heart rate. So far, we would want to look at pairwise comparisons for this one. Then let's look at our interaction effect. Experience and division has a p-value of 0.010, which is less than 0.05. So there is a significant interaction effect between division and experience in terms of heart rate, which means we would also want to look at pairwise comparisons. If you were running this test, that would mean you need to change the syntax. Woohoo! So then we can look at our pairwise comparisons. We can see for experience, we can skip that one. For division, however, we have significant differences. So we'll block those out. Looks like we have a difference between bare bow and compound and recurve and compound. That takes care of our significant pairs for division. And then we can look at our interactions. So again, we can look at these a couple different ways. We could say, are there significant differences between divisions across experience levels? And are there significant differences between experience levels across divisions or within divisions?
Hey, Natalie. Once you do that syntax change, your assumption p-values and your main effect p-values, those don't change, right?
They don't change.
Okay.
Yeah.
Thank you.
All right. So this first one, what are we looking at? Number 1 and number 2? Or someone can describe it. That might be easier.
So within the experience level beginner, there's a difference between barbow and compound, and then compound and same thing. Yeah.
I think the other ones are down here.
Then if you went into like advanced, there's differences in barbell, compounds, Olympic recurve, and compound, and then those are it.
So if we're looking across experience levels, then let's say, are there differences between beginners, intermediate, and advanced? And so then we can split them up. For beginners, we said the bare bow and the compound only. Intermediate, there are no significant pairs. And for our advanced, it was recurve, compound, and bare bone compound. So these are the same ones. Excuse me. There we go. And then we basically do the same thing for the other interaction. Which is, did I delete it by accident?
Did you do the syntax?
I did change the syntax, yes. But I don't know where it is. Why is it missing? Oh, I know why I didn't put it in there. It's probably because there were no significant pairs. Or one of the original questions that was asked when I made this was just, are there any significant differences between? And then I only had you guys answer that one. So we're limited on this one because we don't have the other option, but here we go. We'll just report the ones that we see. You might have additional ones if you decide to run this off of the data set though. Cool. Any questions on data set 4? I'll check the chat periodically. Looks like we're doing okay. All right. Let's round out last 20 minutes on data set 5, which is good timing. I think we can do it. All right. And then I'll change. There we go. All right. A study was conducted to evaluate the effect that different types of squats, being front squat, back squat, and overhead squat, what those squat type effects have, or do different types of squats affect measures of knee flexion, knee joint moments or torque, and torso lean angle. 36 subjects were divided into 3 groups of 12 and randomly assigned to perform one of the 3 types of squats. Shout them out. If it helps, I can pull up the data set as well.
Different type of squats.
Mm-hmm. So type of squat, how many levels?
3.
Mm-hmm. Representing each type of squat, right? And then nominal data because we have been able to categorize. And then is squat a between or within subject factor?
Between.
Between. Ah, my computer hates me. Okay, between subject. Right, and we know that because we said we divided people into 3 groups and they were randomly assigned to perform one of the 3 squats. Okay, what about dependent variable or variables?
Knee flexion, knee joint movement, and torso lean angle.
Yep. So knee flexion angle, I'm going to put torque because it's shorter than knee joint moment. And then torso lean angle. Okay, so 3 measured variables. If you wanted to, for these ones, when there's multiple, I think it's easiest to just say dependent variables are parametric. But degrees of knee flexion and torso lean angle, actually also torque, technically all of these should be interval data because 0 is torque is a vector quantity. And so you can either have positive torque or negative torque, or like positive moments or negative moments, if you guys are into biomechanics. So because 0 is kind of like an intermediate point and doesn't represent the absence of a value, these would all be interval data. So you could say interval, or to make your life easier, if you don't know, you can just put parametric. Also acceptable. Any covariates?
Wait, sorry, did you say ratio wasn't correct for that one?
Yeah, because you can have a torque of 0, because the sign in torque is representing direction. Or if you're doing, technically we're looking at knee joint moments, so moments I know can be positive or negative. Yeah. Covariates, question mark?
No.
No. So what type of test do we have on our hands here?
Simple one-way MANOVA.
Mm-hmm. Simple one-way MANOVA. Test assumptions. Mm-hmm. We have a between subject factor. That must mean we have to test for.
So since it's one way, it would be normal distribution, so homogeneity variance, and between subject design.
Mm-hmm.
And then the new ones are multivariate normality and homogeneity of variance covariance.
Yeah. I'm just gonna put that. Variance covariance.
Is a simple one-way MANOVA the same as, or MANOVA the same as a one-way independent MANOVA, or is an independent between?
You could put a one-way independent MANOVA. That would be the same. Yeah.
Thanks.
Mm-hmm. So again, this one, in this case, is the only one that would be tested in SPSS. Thus, it's the only one that you are going to report on. I'll highlight it down here as well. Okay, let me get rid of this. So we can see we've got our MANOVA output. Whoa, this one's skippy. Okay. I'm just gonna click. There we go. So we see our multivariate test. Remember, this is, so the F that is reported here is our omnibus F ratio, right? And that is combining all of our dependent variables into like a virtual variable. And then we can say, does the independent variable or independent variables, if you have multiple, do they have a significant effect on at least one of the dependent variables, right? So the multivariate test is a part of our main effects. So we'll list that here. I'm gonna scroll. And then based on this output, let me get my highlighter. Based on this output, we can see for squat, again, we are going to average the first 3 values, which in this case, it's just going to be less than 0.001 because they're all the same. I'll come back to that. I just realized I skipped over it. I got excited. Okay. So our multivariate test is showing us that what are variables again? Type of squat. Squat, oh my god. Squat has a significant effect on at least one of the dependent variables. And then I'll just list them here. The flexion, torque, and torso lean angle. This would be one instance where you could put DV, but as long as you explain what those are, you're good. Okay, so that's the first thing we see in the output. Technically, you're supposed to look at the assumption test first, but that was bad on me. It's fine. Oh my god. So now we see Levine's test. And we could see it's like we're looking at, are there equal variances between squat groups for each of the dependent variables? Okay, so we've got these 3 p-values. Again, we always do based on mean, so we'll have a p-value for knee flexion, which is equal to 0.625, which is greater than 0.05. So how would we interpret that?
There's equal variances.
Equal variances assumed between squat groups. All right. Oh no, just kidding. Then for torque, p-value 0.998, which is also greater than 0.05. So we could come to a similar conclusion. And then our torso lean angle has a p of 0.495. Which is also greater than 0.05. So we can also come to the same conclusion. All right, we've met our assumptions across the board. Yay! Okay. So let's go back to our main effects because I got excited. We know that we had a multivariate effect. So at least one of the dependent variables is going to be significant when we look at it across the squat groups or between the squat groups. And we've met our assumption of homogeneity of variance for each of these, so we can accept the results that are given to us in the univariate test between subject effects area. Okay, and this breaks it down. It says squat, and then these are the respective p-values here, here, and here for each of these dependent variables. So I'm going to label this as univariate tests, or maybe univariate effects. And we're going to have one for knee flexion, which shows as p is equal to 0.013. That's less than 0.05. So what would the interpretation be? Give me 1 second. had to make sure that my dinner order was completed by my husband because we're having Korean fried wings tonight. So that place closes at 8. I'm not missing out. All right, sorry. Back to business. How would we interpret knee flexion? How would we interpret the knee flexion p-value?
Just significant. There is a significant effect.
Yes.
Or a difference.
So squat has a significant effect on knee flexion angle. All right. So that means we would look at pairwise comparisons. Okay, for torque, that's the second p-value listed. So 0.20, also less than 0.05. So again, similar conclusion. Squat has a significant effect on torque or joint moments. And we would also want to look at pairwise comparisons. Torso lean angle is the last p-value listed in there. P is less than 0.001, which we know is less than 0.05. So then we could say that squat also has a significant effect on torso lean angle, at which we would also want to look at pairwise comparisons. And I'll highlight these so that we can see them. Oh, no. Oh, no. No. Okay. So now we know what we're looking at in our pairwise comparisons. We're going to be looking at squat, differences between squats for the dependent variable knee flexion, differences between squats for torque, and then differences between squats for our torso lean angle. La la la. So then we can see, right, these look similar to our interaction effects, in which case we're saying what's the difference between the squats for a given dependent variable instead of having two independent variables. So in this case, it looks like there's a significant difference between back squats and overhead squats for knee flexion measurements. If we look at the dependent variable torque, there looks like same thing, back and overhead squat is a significant pair. Do, do, do. Then we can look at differences between squats for torso lean angle measurements. And we've got a difference between front squat and back squat and overhead squat. When I just wrote front and back, it reminded me of, what's that movie, Big Hero 6, where the guy explains how he wears his underwear? First you wear them front, then you wear them back. And it's like inside out, and then front and back. I don't know. Anyways, that was stupid. I'm gonna check the chat. No one has anything to say. Okay. How do you guys feel on that example? Okay, thumbs up, thumbs down. Meh. Does it make sense that the multivariate effect is in effect, though?
Yeah, that makes sense.
Yeah.
Okay, that's good. I just want to make sure, because if you guys were working on your activities, or if you haven't, maybe you have, if you haven't submitted it yet, just make sure that for the MANOVA example, you have multivariate listed as an effect and not an assumption. And then data set 1 again is a one-way repeated measures ANOVA, which I feel like you guys have good practice with. So I will let you assess that one on your own. I'll stop sharing. Are there any other questions before we leave?
What's going to be on this test? One way, two way, and ANOVAs and MANOVAs?
Yes. Or what? One way, two way, ANCOVA, MANOVA, and their variations. But you'll get at least one. There probably won't be one way ANOVAs, but I say that you need to know how to read them just because that's what the independence test is for ANCOVAs. So there will be terminology as usual.
Is that posted? those words?
It just hit me. I did not put that up, so I will do that when we get off of our meeting as well. There are no hand calculations for this one, so yay. Yeah, so there will just be a term bank, and then, like I said, I'll give you like a methodology, and then you have to figure out some information off of that.
So if there's going to be two-way ANOVAs on it, that means we will have to probably redo a syntax, but there's no way for you to see that, huh? How would you even know if we redid a syntax or not?
I wouldn't, but
it only comes into fruition when you look at the pairwise comparisons, right?
Yeah.
Gotcha.
So if you list that you had a significant interaction, then you should also have the pairwise comparisons listed. And it'll be more like how I asked the questions in activity 8, where I was like, are there any significant pairs between independent variable A across independent variable B? And that'll be a hint if you didn't run the change in syntax, and that's like, ooh, maybe I should have done that.
Gotcha.
Yeah, but the questions that are asked are almost identical to the activities. So if you guys, do the review again and you just practice running the data through SPSS and making sure you understand how to reorganize it, and then doing activity 10, that should be plenty of practice to kind of get you ready for the exam. It's the same rigor as normal exam, so it's like a timed activity. But I'll be available to answer questions if you guys ever get stuck. So.
Wait, and did you say there's gonna be three-way ANOVAs on it?
Oh no.
There won't be? Okay.
Definitely
Just two.
not.
Okay.
Yeah, those are beyond us.
Okay, but there will be two-way ANOVAs on.
There will be two ways. Yeah. Two ways, but I won't tell you which ones.
Okay. Thank you.
Mm-hmm. All right, I'll stop recording because